I decided to, this function here that we're looking at, I decided to graph it from 0 to 10, just to give you a bit of perspective of what's going on. We can see from 0 to 10 it goes the concentration of sugar in grams per litre. So your y-axis is grams per litre and your x-axis is time in seconds. Okay? And what you can see is that your concentration of sugar reaches a maximum up here. Maximum is when you get your first derivative equal to 0. So in this particular, it's usually dy dx equals 0, but because our formula is relating c to t, it's going to be dc dt equals 0. So this is where our maximum concentration will take place. Now, what you can see is that to go find the rate at which the concentration increases after 5 seconds, what you're doing is you're on your way up. If you go to 5 seconds, 5 seconds is here. Would you agree with that?
Yes.
And what type of slope does it have? It has a positive slope. So when you talk about differentiation, your first derivative always gives you the equation of a slope. And then you just enter in whichever number you want. Which number do you want for the slope? So for example, if I put in I don't know, t equals 3, I'd get a steeper slope than t equals 5. If I put in t equals, I don't know, 8, I'd get a negative slope. So this generic formula for the slope will tell me if I'm on my way up or my way down from the maximum concentration. Okay? Now, with that in mind, what we're going to do is we're actually going to go about differentiating this, which is no easy feat. Okay? So we're going to look up here, and we see what we're looking at here. I'm looking at two distinct parts, a part A and a part B here. I'm going to break it up like this. Now, we have something called the quotient drill. The quotient drill is when y equals two distinct parts, u and v, which I'm going to use a bit of colour coding for. Then we're going to use dy dx equals product drill, which is u times dv dx plus v times du dx. Now, have to go about differentiating it. First one is u equals t squared over 200. This might as well be the same thing as, I don't know, 3t squared. What happens when you differentiate 3t squared? 2 multiplies by 3 to give you 6. Take 1 away from the power, 6t. Just because it's a fraction, there's no variable on the bottom. So it's treated the same way as 1 over 200 multiplied by t squared, which makes the whole thing a lot easier. You're going to multiply the 2 by the 1 over 200 in the same way you multiply the 2 by the 3, and you're going to get 1 over 100 times t. That's du dx, or sorry, du dt, because you're differentiating t's, not x's. Okay? And dv dt is, this one is different. Okay? It's a chain rule, and you've got to remember what the chain rule means. If I differentiate something like, I don't know, x squared, can anybody tell me what the answer for differentiating x squared is? It's 2x, but there's a hidden part there, right? You bring the 2 to the front and you get 2x, but you also have to differentiate what was in the brackets. And when you differentiate x, what you get? 1. That's why we never bothered putting it in. It's just easier to learn that way. So the way the chain rule works is this. The chain rule works by bringing the 2 to the front and taking 1 away from the power. So now it's to the power of 1. Once again, we never really put in the power of 1. Now I have to differentiate what used to be in the brackets. When I differentiate 100 minus t squared, when you differentiate 100, it turns to 0. Differentiate minus t squared, it turns to minus 2t. Multiply the minus 2t by the 2 and you get minus 4t into 100 minus t squared. Now, I can do it, right? I get minus 400t plus 4t cubed. It's actually not that bad, it's quite manageable. Now, what did we say it's called? dc dt, didn't we?
Yeah.
The change in concentration with time, because the formula says c and t. C is the concentration, or the y value, and the x value is t. Okay? So for this specific question, it's dc dt. Okay?
I'm almost sort of disregarding the letters.
Oh, you can't really. Okay, guys. U to v dx is going to be u, we said, is t squared divided by 200. And then what do we say the v dx is?
400t.
No, it's 1 over 100t. Oh shit.
Minus 400t plus 4t cubed. V, this times v. V is 100 minus t squared per 2. And then what else is there?
du dx is what you need next.
1 over 100t. Now lads, there's a shortcut to this. And this is the good thing about this question. Okay? Usually in a lot of differentiation questions, you got to multiply everything out, you got to factorize, and you got to redistribute it, Frank. You got to redistribute it into a certain way of doing it. But in this question, there's a cheap way out, because what it says is find the rate of concentration after 5 seconds. I can just put t equals 5 in straight away. So I can get is this 25 over 200, because t squared is. Okay. Now you're going to have minus 2000. T cubed is 125. So that's going to be plus 600, because 125 I'm wrong, 500. Because 125 times 4 is 500. And once again, I'm going to keep rubbing out as I go along. Minus 1500 when you combine the two of them together. Okay, so minus 1500. And then once again, we're going to go back in here. 100 minus t squared, 75, right?
Yeah.
75 squared, I haven't got a clue, I'm not that smart. Then 100 of t, so 1 over 100 multiplied by 5.
1 over 100 as well.
Yeah, which is 1 over 20. Then, all I'm going to do next is, finally, I'm going to put all this into the calculator. And I'll get my answer out. So,
I'll do it for you now, sir.
thank you.
Yeah, 700.
Okay, never mind.
65 squared.
What you get?
That's enough.
How much is billion?
Shh. Recording, guys.
Nearly there.
Hold on now.
Okay. In decimals, please. Lads, in decimals as well, please.
3.75.
Sorry?
93.75.
93.75 grams per litre.
Holy shit.
Per second. Because it's over time.
That is crazy.
Wait, Sarah, I don't think you don't have to do the second route.
Okay. You have to do a second derivative because you're not looking for a maximum or a minimum.
Yeah, but sir, it says find the rate at which concentration increases. So it's increasing, not less.
No. Excuse me. Increasing or decreasing relates to your slope. So it's always the first derivative.
Yeah, but just from this exercise, just from looking at it, it would say d2x or d2y dx squared is
No.
acceleration.
No, way out there. Check back the book, sure.
He's right, yeah.
Okay. Now, lads, show the rate of change of concentration is 0 after 10 seconds. Once again, guys, all I have to do is, I don't have to, I can try solve the whole thing, okay, and I could prove that it equals 10, or what's the other way of doing this? There's two ways of doing this. I could try, do you remember what it says here? Prove that the rate of change of concentration is 0. If it's 0, it's a turning point, right?
It's the max.
Sorry? Show that the rate of change of concentration is 0 after 10 seconds.
It's only 10.
Okay, lads, if you look at my diagram, 10 is a turning point. Can you see that? You won't have that in the test, okay? So you'll have to prove that the slope is 0. So to prove that the slope is 0, you want to basically prove that the slope is 0 at t equals 10. To do this, what you're going to do is just replace in 10 and do the same trick. It's going to be 100 over 200, which is a half. It's going to be 4,000 minus 4,000. 0. It's going to be 100 minus 100. 0.
Doesn't matter what you get.
And then it doesn't matter what's there, and you get 0. What we're expecting, a slope of 0 because it's a minimum. Okay? Does that make sense in the context of the graph? After 10 seconds, you're decreasing, you're decreasing, you're decreasing. You hit a turning point. At turning point, your slope is parallel to the x-axis. It means it's no longer increasing at t equals 10. Okay? Alright guys.
That means that, like how, is it like...
The first thing we're going to do is a bonus question called y equals root x over 1 plus x. Same thing, nothing to do with this question here. What we're going to do first and foremost is I'm going to change it using the surd rule. If I have root 5 over root 2, that's the same thing as root 5 over root 2, which is the same thing as 5 to the power half over 2 to the power half. Are we all familiar with that rule? You want to be. Okay? Root anything is that thing to the power of a half. Okay? And surds can be broken up. Any surd fraction can be broken up as a surd on the top, surd on the bottom. Every time. Using this knowledge, I'm going to say root x over root x, 1 plus x. I'm going to change that to x to the power of a half over 1 plus x to the power of a half. I'm then going to look up the quotient drill, which is when equals u over v. Do y dx therefore equals, now please remember order is important in this one. Phi to u dx minus u to v dx all over v squared. Okay, now u equals x to the power of a half. When you differentiate, you bring the power to the front and you take 1 away from the power. Everybody happy with that? Yeah. Next one, phi equals 1 plus x to the power of a half. Same deal. Bring the power to the front and then power to the front is a half. Take 1 away from the power. 1 plus x to the power minus a half. Differentiate, what's in the bracket? 1. So we don't have to put it in. Okay? Now, we have the 2 of these done. We got to enter this into dy dx. So, Connor, this is what you were asking me earlier. Okay? So we're going to have phi times. So it's going to be 1 plus x to the half. Multiplied by du dx, which is a half. X to the minus a half, and then minus u, which is going to be, what's u? X power half, and that's going to get multiplied by du dx, to v dx, which is a half. 1 plus x to the power of minus a half. Close that out. All over phi squared, which is going to be, what's phi squared? 1 plus x. 1 plus x to the power of a half. Squared. I'm going to stop at this point here because now your easy marks are on the bottom. Anything to the power of a half, any number, any letter you can think of, I'll call it m. M to the power of a half to the power of 2 is what goes? Because you multiply a half by 2 to get 1. So the bottom follows the same trend. Pick up some easy marks on the bottom. Just call it 1 plus x. Now on the top we have a problem. It's going to be 1 plus x is on the top, and remember, any number to the power of a minus means what? It goes underneath as 2 to the power of x to the power of a half. Alright, just stop there, right? We're isolating this part here. Okay? We're ignoring the half. The half doesn't exist for a minute. Okay? Now, I'm going to put the 1 plus x to the power of a half just on its own. See, it was here, it's still there. I'm going to put the half on its own. Yeah? Now, x to the power of any minus number is that, like x power minus 2 means 1 over x squared. So, therefore, x to the power of minus a half would mean 1 over x to the power of a half. Yeah, so I'm just turning that upside down as 1 over x to the power of a half. Then, I'm combining everything. See the 2 1s, Simon? Please. Weird. Right? See the 2 1s? They multiply to give you 1. They're gone. And now it's 2 over x to the power of a half, and 2 multiplied by x to the power of a half on the bottom. So, 2x to the power of a half on the bottom, 1 plus x to the power of a half on top. This is a tough question. Okay? Take away. This x to the power of a half belongs on top. It's getting multiplied by a half. Now all my attention is going to this here. It's the same thing as last time. It's to the power of a minus power, which means that I can put it as a It's a positive power. Once again, I'm going to get rid of the two ones like they don't exist. And then I'm going to move the x squared. No, I'm not. So, be that way. Now, I'm going to move the x, what was it, x power half, sorry, on top. Now, what I'm doing next is I'm having a really hard look at what they have in common. At junior cert level, you would have done something like this. C over AB minus D over, I need to use a brand new letter here, BX or BS, whatever you want to do it, right? Now, see the x here. We have to find a common denominator, correct? So to find a common denominator, I multiplied the bottom by x and the top by x. To find a common denominator for this one needs an a on the bottom and a on the top. Would you agree with that? That's at a really primitive level. At this level here, what I'm doing is this. I'm treating the 2 like the b, because they both had b to begin with, didn't they? I'm treating the x to the power of a half like a. This one hasn't got an x to the power of a half, so I'm going to put an x to the power of a half behind it and above it. It has it above it, but not on the denominator. It hasn't got an x to the power of a half as a denominator. And then this one here hasn't got a 1 plus x to the power of a half as a denominator, so I had to put a top and bottom. Now, upon doing that, and this is highly complicated stuff, okay, and it's the only way of doing this, I'm afraid. What we're going to do next is we're going to multiply 1 plus x to the power of a half by 1 plus x to the power of a half. 1 plus x. Everybody alright with that?
Yeah.
And then we're going to do x to the power of a half by x to the power of a half. X. And then on the bottom of that, it's going to be 2 times x to the power of a half by 1 plus x to the power of a half. Now, that's all over 1 plus x. What I'm going to do now is a proposition is that I move this up here and turn it upside down. Now, no, it's upside down. That's over 1. So when I bring it up to turn upside down, the 1 ends up above it. Now, what's going to happen next, guys, is that if you look at it, the 1 doesn't have to be there anymore because that's the top. The top is going to turn into the number 1. Because this part here is plus x minus x, which is 1. 1 multiplied by 1, 1. Okay? The 2x to the power of a half stays where it is. Now we have, this one is the same one as that one, isn't it? So it's like a to the power of 1 multiplied by a to the power of a half. What's the answer to that? 3 over 2, or 1 and a half. So this is going to be 1 plus x to the power of 3 over 2. If you're looking for, like, that's high level differentiation, a lot, I reckon anybody getting a B or below will just be looking to get 8 out of 15, making an attempt in the quotient drill, getting your U and V correct. Just get your U and V correct. The last part is worth like the last 5 to 7 marks.
Like you just did, how did you get 1 on top there?
Here, inside the bracket, x minus x is 1. 1 multiplied by the other one gives you 1.
I don't really get what you did in the bottom there either.
If I have this wheeling, okay, if I label these by letter, so it's a by 2 multiplied by a to the power of a half, and see this thing here? I'm going to call that b. That's b to the power of a half by b to the power of 1. See the way b has the same base, as in 1 plus x has the same base as 1 plus x. That means I can add their powers to be b to the power of 3 over 2. A can't do anything with b because they're different base numbers, and the 2 just stays where it is, and that's where I got 2 to the power of x power half, 1 plus x power root 3 over 2. Now, unfortunately last year, what I did was I tried to do that question within a log question, and it turned out to be absolutely killer. However, I did offer you the alternate method, which is much easier.
We didn't even do the question.
Did we not?
LN.
What? Oh yeah, no. Yeah, we have an easier way for LN. Now you could do that question on its own for the LN one, and then turn the thing upside down. It's ridiculously tough, way too tough.
Just do that question and then put 1 over.
I got a really good idea, right?
This is the same question you're talking about.
No, that was a bonus question, right? ln A over B is what, guys? ln A minus ln B. Simon, you happy with that?
Yeah.
Now, this in turn, question 18, which looks monstrously tough, can turn into this. ln
Could actually decide for the intrusion was an important.
guys, what we have next is this. I can break this up into root x by root 1 plus x. Would everybody be happy with that?
Yes.
Now, I can also use, as I said earlier, my ln A over B formula equals ln A minus ln B. I can therefore manipulate this formula to look like this: ln root x minus ln root 1 plus x, completely taking the need for a quotient drill out of it. The monster we did last doesn't need to be done now. Okay? Now, what we can do next is I'm going to change both of them into powers. X to the power of a half and
Sorry.
cheers. X to the power of a half there.
Don't like
Okay? Right. Now, differentiate. Now, when you differentiate, does anybody remember how to differentiate a log or a log?
And then over 1 over.
Alright, it's one divided by whatever comes beside it. Okay? So, I would have told you it's 1 divided by box, differentiate
The box.
the box. That's what I would have taught you back in the day. Okay?
1 over x, which is power of half.
Exactly. 1 over x to the power of a half, differentiate x to the power of a half, which is a half x to the minus half. How do you differentiate x to the power of a half?
ln x to the power of half is 1 over x to the power of half power x. Power minus half.
Right.
Hold on now.
I had my check.
What we're going to do here, guys, is, would you just be quiet for a second, guys? Remember, anytime you're differentiating an ln, it's ln, whatever is directly beside the ln. Okay? You put 1, this is the derivative of this, it's 1 divided by whatever is in that box. What's in that box is x to the power of a half.
Yeah.
Okay, everybody's happy with the start off, alright? That's a temp marker, okay? Now, you got to differentiate what's in the box. To differentiate what's in the box, the half goes to the front, you take 1 away from the power. Bog standard differentiation, exercise 14.1. Okay? Then you put 1 over 2, and that goes x to the power of minus a half. This x to the power of minus a half, we did it in the last question. You can turn that back into 1 over x to the power of a half. X to the power of a half multiplied by x to the power of a half? X. 1 over 2x. 1 multiplied by 1 multiplied by 1 is 1. 2 multiplied by x. They're all being multiplied on the bottom. So x to the power of half by x to the power of half is x. The 2 goes in front. 1 over 2x. Second one is tougher. Once again, it's the same thing. 1 over whatever is in the box. What's in the box this time is 1 plus x to the power of a half. Then, looking at that, you then differentiate what's here. To differentiate what's there, you put a half to the front. The half goes to the front. You take 1 away from the power. And you differentiate what's in the bracket. But when you differentiate what's in that bracket, what is it? 1. So it's not to be worried about. Then, what you do next is, anything that's to the power of a minus number, you can basically move that to the bottom to the power of a plus number. So it's going to be 1 over 1 plus x to the power of a half. Like the last question, all of this is being multiplied by each other. All of this here, I'm going to circle it in, I'm going to circle it in this here. All of this here is being multiplied by each other. Is everybody happy with that? There's no signs in between them. They're all being multiplied. So here's what we're going to do. It's going to be 1 over 2x. 1 over 2x. And then this one will interact with that one to become what? 2 into 1 plus x.
2 plus 2x.
2 plus 2x will do me. Okay? Now, common denominator. Give this one a 2 plus 2x top and bottom. And give this one a 2x top and bottom. And finally your answer is going to be 2 plus 2x minus 2x all over. What's it going to be? 2x multiplied by 2 plus 2x. You can multiply that if you want. The 2x's cancel. I'm going to get 2 on the top. And then I'm going to get 2x into 2 plus 2x. The 2's will cancel now to become 1. And then if I want to multiply that out, the answer could be 1 over 2x plus 2x squared.
Could you not have just multiplied the fraction just by 2's top and bottom?